And those data points were used to figure out things like sample standard deviation, variance, etc. Keep in mind, don't get confused by the standard D. Standard D, by the way, is probably the most popular of our dispersion measures. Okay? Probably more popular than variance. But the good news is that standard D is very easy to calculate, because all it is what? Standard D, to calculate it, all you got to do is take the square root of the
population variance, RD,
or the sample variance. Right. So the standard D is used more often than variance, because what did I say? The variance, when it's taken as an absolute value or when it's squared, takes us away from the original measurement, inches, yards, feet, temperature, etc. And so how do we get back to that original measurement? Take the square root. If you square something and then take the square root of it, you're getting back to the original data points and the original measurements. So the sample standard D and the population standard D are the most popular forms and uses of measuring dispersion. Okay? So you must be very comfortable with standard deviation, is what I'm saying. So if you understand variance, you do understand standard D. Okay? Just the square root of the variance. Now, last time we were here, we learned some Greek. Okay? And I said, well, what is a mean deviation? It's just telling us how far data points are away from the mean. Okay? And then I said, well, what's a variance? It's another technique to figure out how far observations are from the mean. Okay? We just take each observation minus the mean, and we square each one, add them up, divide by n, and we have something called sigma squared, which is our population, what?
Variance.
Population variance. And you know there is a difference between population variance and sample variance. Okay? Mathematically, the difference is right here. When we get the sample, what are we taking? Is it divided by n, or is it something else?
divided by n minus 1.
Mm-hmm. Exactly. So we see that right here with our sample variance. Sample variance S squared. Okay? Now, if I were to take the standard deviation of the sample variance, I would go from S, right? And I take the square root, that'll give me what? From S squared to, mathematically?
Positive.
No, they're already positive.
It would just go to the regular
A regular
S.
S. That's it.
Yeah.
Right? If I have 14 squared, and I say, if I took the square root of that, that gives me 14. Okay? Math. So in order to get sample standard deviation, take the square root of S squared. To get the population standard deviation, take... Come on, folks. The
Sigma squared. You take the square root of sigma squared.
Yes. Yes. The square root of sigma squared, and that equals...
The population standard deviation.
Right, known as sigma. Okay? Get very comfortable with your denotation, with your Greek. Okay? Not a lot of Greek, about 4 or 5 symbols we're going to use. We're going to use them all semester. Okay? So you have to get extraordinarily comfortable with what those represent. Because if I, in chapter 7 say, okay, take S squared, which of course means this, and do this, you got to be comfortable with that. Okay? And that just comes from a lot of repetition. Now, the standard deviation is used to compare the spread, right? The variance is used to compare the spread, so of course the standard D must also be used to compare the spread, or dispersion. So if I have the Dupree Paint Company, right, the Dupree Paint Company, and I have the standard deviation of a Georgia-based Dupree Paint Company and a Texas-based Dupree Paint Company, okay, and this is bi-weekly income, what can I say about the Dupree Paint Company?
That their profits in Georgia are more consistent.
Because?
Because the dollar amount is less, and it indicates that you're closer to your mean.
Okay. Because the standard deviation is lower in Georgia, that means your incomes tend to be closer to the mean, whatever that number is in Georgia. Okay, so yes, there's more consistency among those data points. And the best word is there is less dispersion. Okay, less dispersion. Okay, less dispersion. Okay, the output, the data points are closer to the mean. So that's when we have a lot of value. That's when we have a lot of information when we compare two standard deviations or two variances.